Is it rolling? Yes, good. Okay, so for the first one, we already said this, but I'm saying it again real quick for the film, that this one converges because it is a geometric series with an absolute R that is less than 1, and it converges to 1 over 1 minus negative a half, right? And that equals 2/3. The second problem just said to approximate the sum of the series using its first 6 terms. Literally, it just means add the first 6 terms together, right? So you have to use a calculator, and pay attention to the negative when it's positive, when it's negative, so you subtract, add, and so forth. And your total sum should have been around 0.6319. Did you ever get something around that? Because we're going to be using a lot of calculators today.
Yes.
So if you don't have your calculator out, you might want to have it handy, because we'll be using it a lot today. Okay, but don't break it. All right. Okay. Keep it off until we use it. Save those batteries. Today we're going to learn how to determine convergence of alternating series. We're also going to learn how to approximate the sum of an alternating series within a specified amount of error. And then the last thing we're going to do is determine if an alternating series converges absolutely or conditionally. 3 big topics today. And yet we'll still have time to at least start a quiz at the end. So
Maybe we can finish our last quiz.
Oh, or finish another quiz. Good. Here we go. So the first test we're going to learn is the alternating series test. This part of the white block here is kind of the formal definition of the test. It says, suppose that the rule for the series is always positive. If the limit approaches 0 and a sub n plus 1 is less than or equal to a sub n for all n, then the series converges. Now, be careful. What we're talking about here is, I should probably tell you what an alternating series is. An alternating series is a series that has -1 to a power in it. Basically, it's a series where the sign changes back and forth. That's why it's called alternating. It's positive, it's negative, it's positive, it's negative, right? So, what we're talking about for convergence, when we talk about a sub n on an alternating series, we're talking about the portion without the -1. Now, there's a really easy way to think of this test. So instead of learning all of this stuff, just think to yourself, if this rule, without the -1, is positive and decreasing, and the limit approaches 0, then the whole series converges. Alright, so if the part of the series without the -1, if the part of the series is positive, decreasing, and has a limit of 0, then the alternating series converges. This whole limit approaching 0 implying convergence only works if it's an alternating series, not a regular series. As we start to work through these problems, I'm going to gloss over the positive and the decreasing requirement. Primarily because if you're ignoring the -1 part, I mean, you can do a quick mental check that it's positive, but here's the thing. If this rule, if the terms are always positive but increasing, then there's no way the limit's going to approach 0. Do you understand what I'm saying? Think of a function that's above the x-axis and always increasing. There's no way that it could possibly have a limit of 0, right? So you can skip the check on decreasing and just say, hey, it's positive, let's find that limit. Limit 0, bam. Anyone need another minute? Okay, so walking you through the first one, suppose we have the function, we have the series n over -2 to the n plus 1. or n minus 1, thank you. You may be thinking to yourself, hey, there's no negative 1 here. She's trying to trick us.
You always
I'm
trick
pretty
us.
sure, I'm pretty sure we picked up on it.
All right, so what you have to do before you start is pull that negative 1 out, right? So pull the negative 1 out. Remember that negative 2 to the n minus 1 is just negative 1 to the n minus 1 times 2 to the n minus 1. Now, I put the negative 1, whoa, I didn't keep it in the denominator, I moved it up.
Oh, you can't do that.
Can't I? Or can I?
No.
Yeah, it doesn't matter, yeah. Or no?
Newton-Berger
Yeah.
law.
So when you're multiplying by negative 1, it doesn't matter, right? It's top or bottom. It's going to do the same thing. All right, but feel free to keep it on the bottom if it bothers you. So now, when we're using the alternating series test, you ignore the negative 1 part, and all we're going to look at is the n over 2 to the n minus 1. Take a look at n over 2 to the n minus 1. For all values of n starting with 1, is it always positive?
Yeah.
What is the limit going to be?
0.
How do you know? There you go.
I'm straight.
That was really fast. Okay. Comparative growth rates really should become like one of your best friends, because they do make the limits go fast. When I did this, I went ahead and demonstrated it using L'Hopital, but when we were doing it earlier today, a lot of people forgot the derivative of 2 to the n minus 1. So this is a nice little teaching moment for the film, that the derivative of 2 to the n minus 1 is 2 to the n minus 1 ln 2. The derivative of a to the n is a to the n ln a, right? And the integral of a to the n is a to the n over ln a. Right? It's been a while since we've done this. So anyway, either way, if you do comparative growth rates, you get 0, or if you do L'Hopital, you get 0. Comparative growth rates, remember, polynomial over exponential. Exponential grows faster. Faster on the bottom goes to 0. Logs, yesterday we were talking about the functions that grow. So you have logs, polynomials, exponentials, factorials. And I was trying to come up with an acronym to help you remember LPEF. So everyone, I came up with 3, but the only one that all of the classes have liked so far was the one that I said, loose pants eventually fall. Okay? So the other 2 are stupid. I said little pollywogs. Remember yesterday I was saying eat flies, so little pollywogs eat flies. And then I had Lucy Van Pelt enjoys football. Right? Because she's Lucy from Charlie Brown.
Oh my God.
I didn't know the last one.
Oh, yeah, Lucy and Linus Van Pelt. And then later on their brother rerun. Right? So, anyway. All right. Okay. Therefore, by the alternating series test, the series converges. It's that easy. So, all you have to do, as long as you have an alternating series, is check the function. If it's positive and the limit goes to 0, it converges and you're done. Let's do another one. So, whoop. Okay. So, take a minute, try this one. Yes. Yes. Because the limit equals 0.
Yes, you
And the argument is always positive. So by the alternating series test, it converges. Yep.
So what work could you show this again?
Not a lot, really. If I were doing the work for this, I would just rewrite out you don't even have to write a sub n is positive and decreasing. As long as I see the limit, that's the main thing I'm going to look for, right? Have you checked that the limit equals 0? If the limit equals 0, then yeah, it converges by the alternating series test. Done. Does that make sense?
Can we find the sum?
Can we find the sum? We cannot find the exact sum, but we can approximate the sum, which we're going to do in a few minutes. Yes,
Do we
please.
need to write out that 1 over n plus 1 is less than 1 over n?
No, because if the limit approaches 0, it's gonna be true.
Wait, so you want me to take
Yeah.
this?
As a matter of fact, we were talking with Mr. Thomas yesterday about the integral test, which also has a requirement that the function be decreasing, and he doesn't even like mention that to his students. He just says, do the integral, right? Because, same thing, if the function's increasing and positive, the integral's gonna go to infinity. So it's gonna fail no matter what, so why do you have to check, right? Okay. All right, try one more.
No. Wait, is this like the nth term test? Or like?
The nth term test says for any series, if the
Yeah.
limit is not 0, it diverges.
But is it like the nth term test for like if it, like you can find out if it diverges, you can't find out if it comes.
Right, yes, this is like, it is not a by
So it
conditional.
doesn't work.
No, it's
Right.
convergence.
Can you just take a limit and or as?
Yeah, but it's not.
And that's just one.
It's not convergent, guys, it's not convergent.
Because they.
Everyone.
The limit has to be 0. For series, it just has to exist. For the limit comparison test, it just has to exist, to be a finite positive number. But for the nth term test and for the alternating series test, it has to be 0. Yeah, I know. You got lots of keys straight. Yep. Just wait till the next one we get to on Monday, we're gonna do one where the limit has to be anything less than 1. All right, so here we go. So when you do this one,
Could I imagine?
it is always positive, but the limit approaches 1.
What I tell you?
When the limit is not 0, that does not mean the function diverges necessarily. It just means that the alternating series test is inconclusive. Alright? The alternating series test only works to prove convergence. It doesn't work to prove divergence. Just like the nth term test only works to prove divergence, but not convergence. On Monday, we will learn another 2 tests that can be used for alternating series where the alternating series test is inconclusive. I know, aren't you excited?
Is this a test that you like?
Yes, actually, yeah. Okay, so that's it for alternating series test. Let's move on to alternating series remainder. This is where you're really going to need those calculators. And this is actually kind of fun. So it looks a little scary to start with, so let me see if I can explain this really clearly. This theorem only works for alternating series. This is not for any series. It has to truly be alternating with the signs plus, minus, like that, or minus, plus, minus, plus. As long as the signs are alternating, right? Here's what it says. Let's say that S is the true and exact sum of the series. And let's say S sub n is the nth partial sum of the series. All right, so S would be the sum of all infinity terms. S sub n is the sum of the first however many, let's just say 10 terms, right? All right, if you were to take the true sum and subtract the nth partial sum, the amount that's left is called the remainder. The remainder is always less than or equal to the next term. So, if I sum the first 10 terms of an alternating series, that sum is, if I took the 11th term, whatever it is, the partial sum I have is within whatever the amount of the 11th term is away from the true sum. I didn't say that well. Okay, so the remainder is always less than or equal to just the value of the next term. That's it. So, yes?
So would it be like the next term is your margin of error?
Yes! And that's exactly what we're about to talk about with error. Yeah, that was beautifully put. Okay, and we're going to kind of write it a little bit like that. So for this first, this is just kind of an example. So that second warm-up, if you remember, we added the first 6 terms of the series, so we got the 6th partial sum. If we found the 7th term, which if you actually did it was 0.0002, roughly, that means that our partial sum is within 0.002 away from the correct sum. And the sum, so the sum has, if we took what we got and added and subtracted 0.002 from it, then the real sum has to be within that interval.
Now makes sense.
Oh, good. Okay.
I'm not raising my hand.
Okay.
Yeah.
This is called the alternating series remainder theorem.
Jokes.
Hey,
Okay. Can you scroll back up a little?
I sure can. I like it because you don't even have to do any calculations to find the remainder, you just find the next term, and that's your remainder. It's really nice, right? So, yeah, so our approximation, first 6 terms, find the 7th term, that's the maximum distance away from the real sum that we are with our approximation. Okay, so let's do an example that uses this theorem. And I need to warn you now that different problems ask for different things related to this theorem. So they're not all going to say, hey, what's your interval that S is within? They might ask for some different stuff. Like the following. Okay, determine the number of terms required to approximate the sum of the series within error less than 0.0001. Then approximate the sum using this many terms. Calculators are not only permitted, but you're going to have a hard time if you don't have one. All right? So, get out those calculators. Now, let's think, I have to give you the series terms, but let's just think about it. How would we know when the error falls below 0.0001 for any series?
Next term is 0.00.
You just find which term has a value that's less than 0.0001. That's all you do. So tell me a strategy that you would use to find that term on your calculator.
Keep on
Yes, check. So you would sit there on your calculator and hand type blah 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 to -1 times 3 divided over 2 or whatever for every single value of x.
Yeah.
Yes and check, yes and
I'd
check,
skip
best
around.
way.
Graph it and
Around.
then look at the table.
No,
Okay,
yes and check.
that's what
That
I'm
was
thinking.
JJ.
you
Gotta
told
give-
us.
Oh,
I'm
JJ.
giving credit to you, JJ. Come on.
Okay,
You want me to take
good.
it back?
Good. Here's what I would do if I were doing it.
That's what
I
was
would
doing.
put the series into Y1 and then just go to the table and scroll down until I hit a value that's less than 0.001, right? Okay, now,
I don't know the other one.
You can't tell me it's fine.
okay, this is our series. The book for some of the problems tonight, it's gonna give you the actual sum. This is your sum S for this particular series. And it's just doing that so that when you find your approximation, you can check and see, oh, look, it really is within 0.001, right? So it's just, that's all. But anyway, so here's our series, right? So this is what I want you to put in your Y1. I was having people ignore the -1, but I'm not anymore. And the reason I'm not is because when we have to find the actual partial sum, it's really easy if you already have it all in Y1. All right, so here's what you type in Y1, and this is where we had some gotchas today, and I'm going to come around and help you with calculator issues in a second. So your Y1, you would do -1 to the x divided by parenthesis 2 to the x times x factorial parenthesis. If you don't have the denominator in parentheses, it's going to do it wrong. It's going to divide by 2 to the x and then multiply by x factorial, right? So make sure you put the whole denominator in parentheses, and then go ahead and scroll through your table. So take a minute or two, type this in, and see what you can find. And I'm going to come around and help anyone who needs help. points.
It's in math.
Yeah, if you need the factorial, it's under math. If you're on an 84, it's math, PRB, and then it's the fourth one down. If you're on an 89, it's second 5, that's where you get to your math menu, and then you go to probability, and it's the first choice. Okay?
Thanks for asking.
Yeah, second, yeah. Table set is where you set up your table, and then table is table. So table would be second graph.
Did you get an answer?
Yeah.
Kid six. What do you mean? You? It's Bryce, my little laptop. I mean, my calculator is not working.
Okay. Okay, tell me, show me your tables.
Will Paul.
You
You get six.
No, I didn't. I don't think
Now it works.
Okay, good. By the way, I have a couple little words of advice for you. If you're looking at your table and you're looking at the y, can I hold it here? Okay. If you're looking at your table and if you look at the y values, a couple of quick things. First of all, what does that e mean?
No.
Times 10 to that power, right? So if we have negative 3e to the negative 4, that means negative 3, but you have to take the decimal and move it 4 places back, right? So it would actually be negative 0.0003. If you are having trouble with rounding and you want to see a more exact value, do you guys know that if you move your cursor over so you're sitting on the y, look at the bottom of the screen and it'll give you the full y value, right? So you can, for me, that's helpful for my eyes. Right?
And it's the absolute value of.
And it's the absolute value. We don't care if it's positive or negative. We just want the absolute value.
Can you have a negative summation? Yeah.
Can you have a, yeah, like a negative sum? Absolutely.
Okay, cool.
So it's usually 4 and 5.
Do you get an equal sign?
What are you doing? Wait, Ryan, you have time?
So if you go to table set, so
Well, it's like 6 for like the value, but then like you would do
okay,
5.
your table starts at 1, it goes by 1.
Oh, it's a of 10 plus 1.
X value, so you
Oh.
Remember, because 6 is where it first drops below 0.00. So you do whatever one so you go.
Good. Who else needs help? You guys okay?
This kid scares me.
Oh my god.
I know.
So,
Surprise, can I go?
We want it less than 0.0001.
so less, somewhere between 4 and 5.
Cool, do you get something like this?
3 zeros and a 1.
Oh, okay.
Yeah,
Cool,
you
did
need,
you get this right?
guys, you need 3 zeros and a 1.
No,
Not
you
2
get every
zeros and a
single
1.
one of
3
those
zeros
zeros.
less than 0.0001. So
You know how much that costs?
tell me what,
0.001.
that would be amazing. Right? Okay, but it's not. So, it's deceiving. If you looked at the actual fifth term, it was 2 point something times 10 to the negative 4th. So it was 0.0002. Is that less than 0.0001?
No.
No, it's bigger. You gotta go to the next term. So it's actually the 6th term that becomes less than 0.0001. Okay.
Miss Price, would an acceptable answer be n equals 5 if it goes from 0 to 5? N equals
You want the, it's asking you, let's see, let's read what exactly it said. Determine the number of terms required to approximate the sum. So based on this question, it actually takes 6 terms. Even though it seems like this is the 6th term, it's actually the 7th term, which is annoying because the series starts with 0. So, yeah, yep. So, it's a sub 6 is your first value of your remainder. So the sum you would use would be a sub 0 through a sub 5, which is actually 6 terms. Okay, I know it's kind of cheating, but you have to pay attention to all those things, so. Okay, so it takes 6 terms added together to get the sum that is within the 0.0001 away.
Oh, we got this now.
No, you can't.
Define the sum, which is the calculator.
I just added, but next one, I'm gonna show you how to use your calculator to do it cute and fancy. Yes, this one I just added them together. Okay, any other questions? All right, you ready to try another one? Let's try another one. Okay,
No, wait, let's go back.
so. Oh, it's not bad. So, it's just, they like to present columns weird, but it's no different. It just looks different. So let's read it and think about it. It says, evaluate the sum from 1 to k of -3 to the n plus 2 to the 4th over 2n factorial, such that its value is no more or less than 0.01 away from the value of the sum from 1 to infinity of the same series, right? So all they're saying is, hey, we want the sum of the first k terms to be within 0.01 of the true sum. All right, oh, yes?
That 2x to their 2n to.
It's a very good question.
Oh, it
if-
doesn't matter, does it?
It does matter.
Oh,
It
okay.
makes a really big difference, right? So 2n factorial is not 2n factorial. So be careful when you type this in your calculator that you do you use x, so 2x factorial. Your calculator will do it right. They'll do 2 times x factorial. If they want 2x factorial, it has to be in parentheses.
Okay.
Yeah, so, this would be for this one. Yeah, don't assume parentheses that aren't there. All right, give this one a try. Put in your calculator and see if you can figure out how far down you have to go. You only have to be 0.01 away. So all we have to do is find a term that's less than 0.01.
N 17.
That's a really big number.
Yeah, it might be farther down than you think.
Well, no, I'm saying I just like the summation in this, like
Oh.
the whole fraction, so like the fractions are like 2 really big numbers.
Oh, yeah, don't do, do
Well,
approximate, don't
actually,
do
it's
exact.
both really big numbers, that means the value's not that big.
I know, it goes up like me.
This whole thing, into Y1. We put the whole thing in the. We put the whole thing in. People are just asking, yeah. Yeah, Y sub 1, yeah, Y1, like for Y1, exactly.
So,
You're looking for the one that is the first one that falls below your required remainder. Because whatever value you look at, that's gonna be the remainder of whatever the sum is for all the terms before that value. So if I add the first 10 terms, then the remainder will always be less than the 11th term.
I learned it all from the.
So I'm looking, if I want the remainder to be less than this, I need to find which term is less than this.
Stair challenge.
And then add all the terms.
No,
Take a bath in wrestling and you see how many matches you can play. If you can get up to 10 in packs.
Say the true sum is all infinity terms, right?
That sounds
Say I add the
It sounds like
first
some,
5,
then your pool would be on
right?
like priority.
The 6th term, the difference
Well,
between the
it
first 5
depends on-
terms and the whole sum is never more than the next term.
No,
It's like a book of
So the next term
Yeah, they got
is your remainder.
use icy
It's the maximum possible.
You can answer Cole.
Yeah, but that'd be done.
No?
Okay, let's say it like this, all right?
Monday, Sunday's 54,
Let's say,
Monday's.
I'm being simple, all right? Let's say the true sum is 100, all right? And let's say the sum of the first 10 terms is 95. That means that the 11th term, just not the sum, just that 11th term, right, is going to be, will be the remainder, like, that next term will show you the difference between this guy and this sum. All right? So, like if I, say my 11th, oh, here's another way to do it. Here's an easier way for me to show you. Say I add the first 10 terms together, all right? And say, I add the first 10 terms together and I get 50.
I feel like it's.
And say my 11th term is 5.
Wait, how'd you do that?
That means the true sum
What?
How'd you do that?
has to be between 45 and
She did.
55. It can't be
I
more
think
than
it's
5 away from
Wait,
what
what'd
I
you do?
got.
I grabbed this choice.
This next term of whatever the next term is after my sum is always the maximum possible remainder. Okay. So if we want to find, say we wanted to find a sum where the max remainder was no more than 5, we would scroll down until we hit a term that was less than 5. Okay, I don't know if that helps or not. All right, but let's walk through this and maybe that'll help a little bit. So, did you all put this into Y1? Which term did you get that fell below 0.01? It should have been the 18th term. Did someone say they got the 19th?
I got 18.
You want me to check? Oh, yeah, just 0.01. Yep. I know, those zeros will get you, right? Okay, so it's the 18th term that falls below 0.01, so our K is 17, and we're going to sum the first 17 terms.
Oh.
All right? Does that make sense? All right, so now we need to know how to sum the first 17 terms. All right, so here's how you do it on an 89. On an 89, on your main window, you just hit F3, and then this little sum thing is like, I don't know which term, like third or fourth down. All right. By the way, if you have the function already typed in Y1, which you should, on an 89, if you want to pull your Y1 value down, you literally type the letter Y, the number 1. You don't have to go to vars. You literally just type a Y, a 1. You have to type it in function notation. So you have to type Y1 of X. And then you do comma, and you do comma X, comma 1, comma 17. This is on the 89.
That's nice, actually.
Okay? All right. If you're on an 84, there's several options. The first one is to just hit math 0. If you're on a newer 84, math 0 should make a little summation symbol pop up. Right? Hopefully that takes care of most of you guys. Another way to get that symbol is to type alpha window 2. How crazy is that, but it works.
Where's that?
All right? So either math 0 or alpha window 2 should get the little summation symbol to pop up. If you're on an older 84 or an 83, say, hey, you know what? There's nothing wrong with 83, right? Good hardy calculators. Okay. If you're on an older 84 or an 83, here's how you have to get it. Are you ready?
So rusty.
Okay. First, you hit second stat, arrow over to math, and then choose option 5.
Just type one.
It'll say sum, okay? Then you could do second, stat, arrow over to ops, and choose option 5. It'll say sequence. All right? Under second step? Yeah, okay. And then pick 5. Once you have some sequence, then you can do function, comma, x, comma, lower bound, comma, upper bound. And by the way, do you guys know on the 84 how to get your y1 from vars? Right, vars, like y1.
What was your value?
Here, I'll show you how to get it on yours. Have you done vars? Okay, so let me make sure I do right. So you use the vars, okay, and then arrow to y bars, and then just hit enter, and hit enter. Okay, and then go comma x,
You gonna win tonight, Will?
comma 1, comma 2, and let's see what happens. There you go.
I might go to that. Try that.
I'm not about
Does everyone know how to get y1 onto their window, so they don't have to sit there and retype it all?
It's not.
Okay, through bars. Got it?
Yeah.
Okay, good. All right. Hey, last topic of the day. I'm sorry? No, it really is. Okay. All right. The last topic is for absolute and conditional convergence of alternating series. Alternating series can do one of 3 things. They can either converge absolutely, they can converge conditionally, or they can diverge. So if you show that an alternating series converges, there might be problems where it asks you, does it converge absolutely or conditionally? How do you know? Here's how you know. If the series, the absolute value of the series converges, if the series of the absolute value of a sub n converges, then the whole thing converges absolutely. If the series with the absolute value of a sub n diverges, but the series, the original series converges, then it converges conditionally. I know this is going to seem weird, but it's actually really easy. So the absolute value, in essence, just means if you rewrote the series without the negative 1 part. So if you rewrite the series without the negative 1 and that series converges, then the whole thing converges absolutely. You don't even have to check the alternating series because it automatically does. If you rewrite the series without the negative 1 and that one doesn't work, but the alternating series still converges by the alternating series test, then it converges conditionally.
So we have to like write that down on a test whether it's a conditional or absolute conversion.
You know, I haven't looked closely enough to see if he asked that, but it's definitely in your homework.
What would we say convergent and like with conditional convergence if it was just?
Well, it only applies to alternating series, right?
Like, if we were just to ask like whether it converges or diverges, would we?
You would not have to specify, but if he asks you, you'd have to answer it, right?
You know, I think there should be more definition questions on our tests.
More definition questions?
No, because I would lose.
Multiple
You
choice.
would lose the game.
No, definition, because concepts are very important also.
Or you could just be memorizing the definition.
Brian?
What, you just deflated
What
him.
just happened?
He just
Brian?
literally went down.
What
like
did
that.
you do?
I just went from taking
Oh,
6
goodness.
and
Greatest take over.
It's-
I was savage.
It's late on Friday, just be forgiving. All right, so here we go.
I'm exhausted.
So first example, determine if each series is convergent or divergent. If it converges, classify it as absolute or conditional.
Can you go back to the previous slide? I think I missed something.
Oh, sure.
Wait, Miss Rice. Like, you said that there would be like 5 parts on the test, but if like the first part's the convergence or divergence, what are like the other parts?
I know one part is just find the sum. I
Is it
know,
a geometric series?
yeah, geometric and telescoping, that's all we can do, right?
Yeah,
So it'll just be, oh,
Yeah.
so nice.
And
I'll watch the
then
fractions gonna be.
That's like-
one part, I know there is at least one question in one part that has to do with error, right, that we just did. But, I'd have to look at the rest, I'm sure the rest is on Taylor polynomials, Maclaurin polynomials, and power series. Yes.
Yeah, I got it.
Yeah, I should probably not tell you, but it took me, I just finished today during my planning, the smartboard notes for just 9-9 part A. I've been typing them and working them for 3 days, and I finally finished today, and it's only like 6 or 7 slides, it's short. And I literally was spinning by the time I was done. I'm like, oh my gosh. So I'm hoping between now and when we do it, that I will feel refreshed where I can make you guys think it's simple and easy. That's the goal,
Well, now we have it.
right?
Well, now we know it's impossible.
So, here we go. It's really not bad, it's just so long. It's long, each problem is really long. So, all right. So, yeah, I know, we all like quick. Hey, these are quick. You'll like these, they're quick. Okay, here we go. So, the first thing you do when you have to decide if an alternating series converges absolutely or conditionally, first thing you do is you check the absolute value of that series. So, all you do is rewrite the series without the -1 part. Are you okay with that?
Yeah.
Okay. No? Yes? Good. Alright. Now, just tell me this. Does the absolute value of this series converge or diverge?
Divergent.
Diverge, how do you know?
P-series.
P-series,
One half.
right? Don't we love the P-test? Yes. Okay, so, because this one diverges, then that means this guy is either going to converge conditionally or diverge, right? It can't converge absolutely, because this guy would have to converge for it to converge absolutely. Alright, so now we have to just check and see if this guy converges based on the alternating series test. Well, the alternating series test just says if the limit of a sub n, which is just the 1 over root n, if that limit approaches 0, it converges. Does it approach 0? Yes. So then this converges conditionally.
How does it approach
Alright.
0?
Because it's 1 over root n, which is going to approach 0. Okay, so since the absolute value diverges based on the p-test, we need to check the actual alternating series. After you check by using the alternating series test, the original series converges, so it is conditionally convergent.
So why do we need to know if it's conditionally or?
Because we will ask you.
That is
Why?
not a good answer.
Okay?
I'm
Alright.
not happy with
Wouldn't you
that.
wanna ask me
Dylan doesn't.
I expected an essay
Well,
on why
hope
it
that
matters
converges
on my
absolutely.
day tomorrow. By 5 a.m.
Yep,
Tell me if this.
which is gonna help you out
Why on
next
earth
month.
would you be awake at 5 a.m. on a Saturday?
I'm gonna get up at like 6.
I'm awake
Okay.
at 5 a.m. on
So, we're almost done, guys, let's focus. So, here we go. Suppose we had to check this guy.
No.
Tori's
No.
eyes literally just went like that.
You can't do that.
No, no. This
So-
Friday, it's a Friday afternoon.
-1. Oh, but it's I was surprised. We're actually gonna have to.
No, you can take a square root because all of the exponents end up being divisible by 2.
Yeah. Because you're starting with 1,
Yeah.
So the top starts
so
at.
it's 2 over 2.
You'll always have an even number in there, right? Because you have an even and an odd every time. Yeah. So, so anyway, because of that, what's funny about this though is it alternating? It actually goes like negative, negative, positive, positive, negative, negative, positive, positive, which is kind of bizarre, right? But regardless, if the absolute value of this thing converges, then it converges absolutely. So I want you to check and see if the absolute value of this series converges.
Would the actual value of this be 1 over 2?
Uh-huh.
Okay.
Wait, isn't it always,
I think the absolute value of all this term is 1, right?
you do 1, and then that's 2, right, right, we have, doing it.
Um,
Divided by two.
Oh, the absolute value of all this.
Divided by two. Yeah, oh yeah, yeah. So it's just.
Nikisha, the absolute value of numerator is just 1, right?
Because it's just on a negative one, right? So all this exponent, all it's doing is making it go positive one, negative one, positive one, negative one. Yeah, right, see? Okay, so, guys, just because it's a kind of a convoluted exponent doesn't make it any different when you take the absolute value of negative one, no matter what the exponent is, that absolute value is just gonna be one, right?
What is the
So this is the absolute value of it is just the series from the sum from 1 to infinity of 1 over 3 to the n, which you could also think of as what whole number to the, or what number to the n? 1/3 to the n, right? Does 1/3 to the n converge or diverge?
Diverge. No, wait.
Converge.
What?
It converges by what test? Geometric series, right?
Ah, yeah.
This is a geometric series,
Yeah.
so because this converges, you can just stop and say, yes, the original function converges absolutely.
Yeah, it's not 3.5, it's 1/2. It's 1/2, sorry, you're wrong.
What are the G?
All right,
Oh.
you gotta switch it to start.
Oh,
Less than
yeah.
one
I forgot.
Okay, so anyway, did you sort you have questions?
I'm good.
But you got down 2/3.
Alright, so if the absolute value converges, you're done, because the whole thing converges absolutely.
Absolutely.
Alright,
I got that too with 2.
alright,
Okay, so we
last,
Pi.
this is the last one, but that doesn't make it the easiest. I'm saving the toughest for last. Yes,
If we find that the absolute value is divergent, we have to go back.
then you have to go back and check the alternating series. Yep. Okay, so, this one is harder than it looks.
Do you have to do the limit thing?
So,
I'll take that as a yeah.
if you try the limit comparison test, you can try it.
It's not gonna work.
It might not work well.
I called it.
Okay.
I called it.
So I don't know whether or not then one over natural log of 10 works.
That's the whole dilemma.
It works, Mr.
Okay, except it hasn't, because you don't have an answer.
What's the answer?
Alright, so anyway, here's the thing. If you use either of your comparison tests and you compare this with 1 over ln n, you don't know if 1 over ln n converges, right? So you can't use a comparison test with 1 over ln n. Because
Yeah, you don't know.
you don't know. So you might need to do a comparison test, right? Because it's not nth term, it's not geometric, it's not a p-series, right? So you could either do the integral test, which we tried earlier today, and you end up with infinity minus infinity, which of course we know is inclusive, right?
Wait, really?
Yep.
I thought it was infinity.
So anyway, so the only way that I saw to do it that worked well was to do a direct comparison. Instead of comparing with natural log 1 over ln n, I compared it with 1 over n. So I want everyone to take a minute.
Wait, 1 over n?
1 over n. And try to do a direct comparison test on this function, the absolute value, right? Absolute value, with 1 over n.
Doesn't it still work
I'm
with?
kind of giving it away.
Yeah, I just.
Do a direct comparison test
I
with
just.
1 over n.
That's part of it.
You have to think about it, and you can kind of use comparative growth rates to make that decision.
It's divergent.
Yup. No. It's divergent.
That's what I just said.
As in the novel?
Yeah.
It's smaller than the
Is it a new movie?
It's in the
I
novella.
was trying to make a pun that didn't work.
It's a new movie.
I'm not coming.
Yeah, when does the Legion come out?
What do I'm doing?
What?
Ryan and
Yeah.
Right.
What's up? Oh, William.
He's not here right now. Dude, Tanya got back yesterday.
Oh, what happened to?
You guys do that? You guys do
Of those
Tommy
three,
Hartle
which one is
sucks.
my favorite?
Will, like seriously, what happened to Tommy yesterday?
You would have to compare.
Do you watch the game, right?
No. Do I ever watch the game?
So.
You should, Brian.
Ryan, come to the basketball.
Nah, man.
Brian, you can sit man.
Cole, I don't want to. Cole, I don't want to.
Ryan, you can sit with me.
Oh, no. Ryan, you can be on the bench.
You can be on the bench with Will.
No, you can be on the bench with Will. And Grundy.
I am really scared right now.